Okay, and you can talk about the game meanwhile.
Yeah, so I just want to kind of talk about the game in from like a more kind of artistic and lore perspective. So The Seeker is a game that I'm working on together with Vida, and there's also one pixel artist on the team, and a few of my kind of sound designer and music friends, because that's like my background, which has some relevance to the game that I'll get into a bit later. Uh, so the idea behind the game is that it's a sci-fi 2D kind of Metroidvania style game where you play as one of the first settlers on an alien planet that was just discovered, and the alien planet is all covered by ice, kind of like Hoth from Star Wars, and all the creatures are living in like deep cave systems below the surface, and there are a lot of things to explore under the ground, and the kind of vibe that I would like to uh, express with this game is kind of like playing something like Red Dead Redemption or one of these kind of more sandboxy games where it's kind of the format of a Metroidvania, but at the same time you have much more freedom and the world is much more kind of organic feeling where you don't really have any specific like bosses or kind of scripted events, but it's more like you engage with the ecosystems there, uh, and kind of a bit more like something like Rain World or something like that. Uh, and on top of that, there's also a bunch of like the combat system is much more similar to something like Risk of Rain, for example, where it's kind of a combination of a very calm atmosphere in the actual like scenery with like very hectic combat with a lot of like explosives and stuff in the actual combat part of the game. Uh, and then on top of that, uh, the game kind of has like multiple layers to it, where the kind of surface layer of the game is what I just described, like a kind of adventure game um, where you explore a planet and stuff like that. But on a kind of more technical or deeper level, it's kind of like an experiment that I want to try out based on an idea that I got interested in like the in my sound design background, and it's an idea about essentially uh, sounds and visuals uh, ultimately being all about mathematics. And just like in music, for example, you have the idea of root notes and key frequencies, where let's say you have a sound playing at 100 hertz, and you can take that as your root, and then once you multiply it by two, for example, you get octaves, and if you divide it by two, you get octaves as well. And and the same you can apply to, for example, hertz, which is the same oscillation, or FPS, which is the same oscillations per second in animation. And then you can do this kind of octave transposition to uh, kind of sync the the audio to the animation. So in this case, we have the audio root frequency at 48 hertz, and then all animations are playing at 12 FPS, which is exactly two octaves. So two times divided by two below the musical root note. Uh, and then so all music in this game kind of is based on the 48 hertz, and then all the kind of harmonies are derived in that mathematical sense, and similarly all the visuals are kind of synced to the 12 hertz kind of thing. And then the same thing is happening with like the tempos of the music. So the tempo of the music, the BPM, is also a number of repetitions per second or per minute, and that is also synced uh, to those previous two. So in the end, what's happening is that kind of the whole thing is kind of beating to the same clock, uh, and you as the player become a kind of instrument in this whole uh, thing, and everything you do is kind of by definition synced to the tempo, and it's not meant to be a like a rhythm game where it's not meant to be super obvious, but it's kind of an experiment in trying to find out how that kind of super synchronized experience would feel, and what kind of mental state it would put you in, together with like the visuals and all that, kind of trying to create like a sense of wonder and kind of a meditative experience where you on one hand explore the planet, but on the other hand you're presented with like this mathematical structure that you're kind of exploring as well. So that's kind of like the kind of artistic and lore explanation, and then maybe Ida can tell more about like how we're tackling that from the. Oh yeah, there's some more gameplay here. Here without the backgrounds. So it's all like super early on. And you can also, yeah, maybe this as well. This one has the backgrounds, but it's kind of missing some more context. And yeah, I think that's kind of it. Is super early in development. So, and here's some more like animations that we have to clear.
So, first of all, I want to add something to your comments about the game design and why I'm personally kind of inspired for your game idea and why I decided to join the project and work with you. I really like the kind of aesthetic and vibe that kind of reminds me of a game like Hollow Knight in its kind of mystical cave exploration. And I know that you are really into like you said, these mathematical ratios and fractals and things like that. And the way you describe this mental experiments of trying to really synchronize all the sounds, make them with really perfect timings, and have the visuals and the music and the sound be following mathematical ratios and things like that. I'm really looking forward to how that's going to turn out, because I think it's going to be a bit of a psychedelic experience, if you will, where you can kind of feel the fractals and the mathematics of the world kind of ticking like a clock. Yeah, and this brings me on to the thing that I've been working on, which is a very clever asset-driven animation system for purpose-built for this game in Rust and Bevy. So what we have is we can create asset files that are scriptable. And our game is running at a fixed time step tick rate of 96 hertz. We chose 96 hertz because it allows us to have a lot of granularity for subdivisions. But also it's a clean multiple of, like C12 said, the design frequencies of 12 hertz and 48 hertz for the music and the visuals. And what we can do here is we can create different animations that are by having the texture atlas. For example, yeah, this is the raw graphics. So for example, the idle animation, you can see for the player or the run animation, but there is this script file that tells the game how to play it. And in this script file, you can set some metadata, and the whole format and the animation system for our game is designed to allow everything to be scripted and coordinated and orchestrated at very specific timings, so that C12 can implement its artistic vision, where the sounds and the footsteps and the frame transitions of the animations happen with perfect timings, with perfect multiples of different ratios. So, for example, this tick quant parameter means that this animation is always going to start to play as if it's synchronized and to a multiple of 8 ticks. So the animation is going to advance 1 frame every 8 ticks. So that makes 12 FPS. And this tick quant means that whenever you press the movement key and the game transitions to this animation, is going to kind of round and quantize the current tick number to a multiple of 8, so that the animation always plays in lockstep with other animations. And we can add these script actions to do things at specific conditions, and it's very flexible. I use Serde for this. We can go to the file format implementation is written with Serde structs like this. And here you can see how, like, we have different run conditions. These are the triggers that trigger specific actions in the script. So, for example, a certain tick number, or a tick quant is for like a periodic thing. Like if you say run every n ticks 8 plus 2, that is going to run on every multiple of 8, but like offset by 2. So if I uncomment this, this is going to change the color to red every 8 ticks, but like offset by 2. So like on tick number 2, on tick number 10, on tick number 18, and so on. And this is going to change it back to white. And this way we're going to make a blinking effect. And it's going to always be perfectly synchronized with the tick rate. So for example, with, if I run the game right now, wait, I mistyped. You can see that if we have wait, what happened? Again, things break when you want to present them. What happened here? Yeah, so like when you get the damage, you have this blinking effect. So if you like, you can switch between idle and run and apply this damage effect. And this works by, if we look at the Rust code, you will see it's actually really elegant. I really like it. Right now I have this placeholder system for testing where I just check for different inputs, like different key presses, and I tell the animation system to play a specific animation. So for example, the idle animation or the run animation. And we have these slots. The slots are like modifiers, like Boolean variables that you can set for the script. You can say like direction left, it becomes true or false, or direction right becomes true or false, or damage becomes true or false. And here in the script, we can do things like run on slot enable, direction left, and change to a different frame index, set frame now and go to frame 0. And on run on slot enable direction right and jump to frame 10. And this way we can like do different sub loops and different kind of things in the animation, and it's all orchestrated from the script file. This way the Rust code becomes very simple. The Rust code just needs to set the variables. It needs to tell the animation system which animation to play, and then control the variables for the scripts by setting the different slots to true or false. And in the script, we can orchestrate things by saying, like on a specific animation frame or on a specific tick. Like I could, for example, just add a new script action here and say run on tick 0, and do something like action set sprite flip or set sprite color, and set the color to green, just as an example. And then, for example, run at milliseconds, say 2000, and we'll set sprite flip to flip the sprite along the x-axis, or let's do the y-axis just to make things more interesting. And when I write this, it's in the asset file, so I don't need to recompile the game. I can just run the game. And when I go here, wait, what happened? So I'm now in the idle animation. Oh, something's broken. Something's broken. Oh yeah, we have. Oh, it's run at tick instead of run on tick. I miss. It's a syntax error in the animation file. Um, so see, now it's green and it flipped because like we queued up those actions in animation. So now I can like play. And yeah, if I reset the game, you'll see it will start playing the script, and after 2 seconds it will flip. So you can use these script files to basically implement any sort of artistic effect by changing the color, by flipping the sprite, by changing the transforms. We also have script actions for directly manipulating the transforms in the engine, so you can make things move around. If you want to make like a vibration shaking effect, you can do it from the script by changing so like, for example, instead of doing run at milliseconds here, I can do, for example, run every n ticks and say every, say, 64 ticks. I am going to set the sprite flip to true, and every 64 ticks plus 32, like to offset it, we're going to set it to false. If we run that now, you're going to see how it's going to alternate between the two states. It's just flipping up and down. And I can also add a randomness to it by saying like something like RNG percentage equals to 50, or let's say 75 for this one, and 25 for this one. And when I run it now, oh, I think oh yeah, I should have, it's not in quotes. Yeah, it's a syntax error again in the script. So when I do this, now it's gonna have like a random chance of flipping every 64 ticks. See, sometimes it does it, sometimes it doesn't. So you can have also randomness in the scripts like this. So this is very powerful because we can add any sort of custom actions to our animations, and we can control the exact timing. So you can say at tick number 16, you should play a footstep sound. And at tick number 8, you should play this other like footstep or jingle sound, and but you should do it with a 50% probability so that you don't do it every time, and there it's like a random. And every 5 ticks you should like change the color of the sprites, and then every other 3 ticks you should change the color of the sprite and do like different effects and different things like that. And for the movement, we can also make it synchronized to the tick rates by, say, for example, changing the transform, doing like a physics move on the character controller from the script, so that the enemy is walking in perfect cadence with the music and the sounds, and you can play the footstep sounds and the music and the frame animation transitions, everything perfectly synchronized to the tick rates. It's going to be very interesting, and I developed this system specifically for this game to allow C12 and the artists to realize this artistic vision of having these elegant mathematical ratios of overlapping visuals and sounds. So we're going to be doing different visual effects and different sound effects from these scripts, orchestrated with very precise timings. And the next step I'm going to do here is implement a custom audio system, because we realize that Bevy audio, it does not have the consistent timings we need. If you just play sounds from Bevy, sometimes they'll be a little bit delayed, they'll be a little bit offset, they'll have kind of unpredictable timings. So I'm going to make a custom audio stream that feeds into Bevy audio that is going to also be synchronized with our scripting language here, so that we can play the footsteps and all the other sounds and so on with perfect timings, and I can generate the audio stream in real time with the tick rate of the game. It's going to be very interesting, and I'm really proud of how this turned out because it gives so much creative control to the artists. It's asset driven. You don't have to change any Rust code. The Rust code for the movement of the player and the character controller, it can just set these different variables to true or false for the scripts. And you can do different things in the script. Like here, for example, we are looping between frame 0 and 9, and that's when the player is facing to the left. And when the player is facing to the right, we'll loop between frames 10 and 19. And when the Rust code sets direction left to true, we are going to jump to this frame index. And when it sets to direction right to true, we're going to jump to this frame index. And then we can do a blinking animation, blinking effect, and other things from the script. So it's kind of a really convenient scripting language almost, but it's not a programming language. It's a declarative asset file format that is based on TOML. As you can see, it's just TOML syntax. And I load it as an asset with Serde. And then the game code will parse this, and it will queue up all the different actions. If we go to script.rs in the game, you can see that like I have this extensible trait system which allows us to have different variations on the script format. So we have the basic scripts which are used for things like level events. You can have a general purpose script if you want to make something like a cutscene or something like some background events happening on the map. So say, for example, you want to say that after 5 minutes, an enemy should spawn, or in like every 50 seconds, some enemy should spawn or some NPC should appear. You can do that from scripts. But we also have the animation format, the one that I was just showing off, which is an extension of the basic script format. And if we look at assets animation.rs, you can see that here I define the animation extensions. So a new set of run conditions and actions that are specific to animations. And I'm using this special extended script struct, which combines the general purpose scripting stuff with the animation specific stuff to create an enhanced combined extended file format that supports both of them at the same time. So you can use any of the parameters that are available in all of the different scripts, but you can also do animation specific things like changing the frame and changing the sprite color. And it's very composable in this way. I implemented it with Rust traits. You can see the traits here. So I have a trait script asset, which has all these other traits to make it extensible. It's a little bit over-engineered, but I think it's worth it. So it can have like settings and access to arbitrary Bevy system parameters to do different things. And we can have a trait for the different action types and different run conditions and the different parameters that you can have in here. So I'm doing some very clever Serde trickery to kind of combine everything into one format. If you look here, I'm using all these attributes with Serde renaming and tagless enums and flattening between the different structs and so on, so that it can be very intuitive for the artists to write. They don't need to understand the structure, the underlying structure in Rust. Everything is combined together. We have like this common script which flattens these several different structs to combine all of their fields into one, so that here in the actual file format you can specify the run condition, extra parameters, the action, and so on, and you just do it under one script section like this. And all of it is merged together and then parsed by Serde into this struct, which automatically generates all of these separate substructs, the nested structs for the run conditions and the parameters and so on, and the actions. And here's the implementation. So I have this tracker. This keeps track of all the different actions that are queued up. So these are the actions, the actions that are supposed to run on specific ticks, or the periodic actions on different slots, enabling, disabling, and so on. This is like the internal states of scripts. And here is like the initialization and update, which will take the Rust structs that are loaded from the asset file and initialize all of this stuff. And then every fixed time step update, it will iterate and it will go through here and it will check the current tick number and the timers and so on, and add different actions to the queue to be performed. So the script driver system in Bevy that I have in script.rs is generic. You will see like I have script driver system, which is generic on the trait. And it will use this clever Bevy syntax to access arbitrary parameters from the ECS. It will load arbitrary data based on the associated types of the traits and that's how I can make it generic. So I can have different asset types. I can have an asset type for my general scripts and an asset type for my animation scripts, which is the extended format with additional actions and run conditions and so on. And here I have an API that is similar to Bevy's own animation API, where I have a ECS component for the animation player, and you can tell it play handle and give it a Bevy asset handle, or like play key or something, and it will transition between playing, stopping, loading the asset, and so on. And it will drive this whole thing. So all of this complexity is conveniently hidden under the hood here, and C12 and the artists can just work with the asset files and not worry about any of the Rust code. And it's really convenient because if they want to make certain sounds or certain visual effects play with very specific timings and coordinate everything to make it feel really good, they can just do it from the asset files declaratively from this TOML-based file format without touching any Rust code. You can see how the animation stuff also has its own sprite animation tracker, which extends the common script tracker, and it does things specific to the animation playback. All of this is put together using these special Rust traits. So I'm using the Rust type system to allow me to have an extensible file format. In the future, I could create another asset format that is based on the same architecture for other things. So right now we have sprite animations, but say in the future I want to do some sort of gameplay scripts where on something like different weapon attacks or like enemy AI or whatever. So I could just do something like enemy AI script formats and implement all the Rust traits and extend the common scripting format with additional AI specific actions for pathfinding or whatever. And we'll have a new asset format that has the same syntax and supports the same common things like run at tick, run every n ticks, run at milliseconds, and so on. All of these common parameters will still be supported, but I can extend it with additional AI or pathfinding parameters in the same way as I did here for sprite animations.
Yeah, and maybe just I'll just add one more thing is that we're trying to basically make this game as open source as possible. So currently, the entire code is under the same license as the Bevy engine. And that also guides a lot of the decisions about how to organize the code, etc., so that it's very easy for other new contributors to start adding stuff. And we're kind of trying to treat this game as a kind of a creative canvas where there are the certain mathematical rules that I kind of set out, and then anyone can just make their own things based on these rules. And it's already like the most obvious with the music sound part of the game, where we're essentially all making, like me and a few friends are making tracks and then sharing the individual parts, individual like stems of these tracks. And since they're all using the same tunings, they're all compatible with each other. So it's like a massive remix thing where everybody can like pick and choose like which parts of someone else's track, etc. And it's like a massive growing pile of music that's just being produced. And I would like to have the same for other aspects as well, and allow like as easy as possible of like a community creative thing happening. So yeah.
All right, perfect. It's, yeah, super cool to see this. I think I really like this focus on being able to create some kind of file that you can go through and be very like, I guess, terse in what you're saying, but have a lot of complex things that can happen from it. And so it's really cool to see. And I guess like even as an animation designer, being able to go through and like try different things, put different things together. I feel like a lot of games definitely follow the same path when they go for animations and like how you go about that process, but this one seems a lot more dynamic. And so I'm quite interested in taking a look through the code that sets this up. And so you mentioned like the whole project is open source. Are you thinking of like maybe extracting this idea of taking the assets pipeline and abstracting that into a crate that other projects can use as well?
I've thought about it, but right now the code is kind of quite interentangled with some things that I've made for this game. It's, for example, instead of using Bevy's usual fixed time step, I have my own fixed time step because I didn't really like the way that the structs are represented in Bevy. So I kind of re-implemented a few foundational things. And also I'm not really sure how I can make this project independent, because a lot of the actions that we have here are represented using Rust enums. Like you can see, I'm just matching on an enum to implement the different things like set frame next, set frame now, set ticks per frame, these different things. So naturally, we are going to have a lot of things in this syntax, in this file format, that are going to integrate with all kinds of different game-specific parts that are kind of specific to this game. So I'm not sure how I could pull this out into a separate crate to generalize it. I think I could, but you wouldn't be able to use it just as a Rust crate. You would have to fork it and add your own commands and your own integrations to do your own game-specific stuff if you're interested. So I think the most realistic way to make this useful for other people is not so much to try to make it into a Rust library with some sort of API that lets you hook into it, because it's supposed to kind of integrate with your code base. You're supposed to have these kind of enums that define all of the custom things you want to do from your scripts. And I don't think you can do that without modifying the code. So I don't think this would be that useful to try to make into a crates.io thing that you can just use as a dependency. I think I would much rather do it as some kind of template repo or something like that in the future, where you would be able to, I could maybe take the code that we have, strip out all of our custom actions here, and publish that as like a separate GitHub repo or like a gist or something. And so people can copy paste it and insert their own custom actions to customize the file format for their specific games.
Yeah. Okay. Yeah, that's super cool. Yeah, I do like that idea of kind of like making a template that people can start from. And I mean, even if it's a template for like education and kind of learning what the process is, that would still help people, I imagine. All right. Well, yeah, thank you for showing this off. It's really cool kind of seeing the background of what's happening here. So I'll make sure to include links to the Seekers GitHub repository and Discord server and all of that in like the blog post that I'll put it afterwards. But for now, we are at the end of the meetup. So thank you both for showing this off.
Thanks for having us.
Absolutely.
Thanks for
We'll be
having
back
us,
in just a second with the closing.